Welcome to Learn Chemistry Together. This video is about practice problems. Structural theory of matter. Our target audiences are introductory organic chemistry students. The goal is master drawing constitutional isomers using valency and systematically exploring carbon backbones. We're diving into practice problems on the structural theory of matter, specifically how to systematically find and draw all constitutional isomers for a given molecular formula. Let's start with a step-by-step solution for problem 1A C3H7Cl using the three-step method shown on the whiteboard. Step 1. Determine valency. First, identify the number of bonds each atom in C3H7Cl. Carbon, valency equals 4 tetravalent. Hydrogen, valency equals 1 monovalent. Chlorine, valency equals 1 monovalent halogen. Step 2. Highest valency network. Connect the atoms with the highest valency first to create the main chain. The three carbon atoms form a continuous backbone. The monovalent atoms H and Cl will attach to the outer open positions, the periphery, of this backbone. Step 3. Explore variations. Place the chlorine Cl atom at different distinct positions on the three-carbon chain to find all constitutional isomers. Variation A. Attach chlorine to carbon 1. IUPAC name 1-chloropropane. Variation B. Attach chlorine to carbon 2 middle carbon. IUPAC name 2-chloropropane. Next is a step-by-step solution for problem 1B. Finding all constitutional isomers from molecular formula C4H10 with the method shown in the provided example. Step 1. Determine valency. First, identify the number of bonds each atom in C4H10. Carbon C, valency equals 4 tetravalent. Hydrogen H, valency equals 1 monovalent. Step 2. Highest valency network. Connect the atoms with the highest valency first to build the main carbon skeleton. There are two unique ways to connect four carbon atoms together. Network A, a straight chain of 4 carbons. Network B, a branch chain, a 3-carbon chain with 1 carbon attached to the middle. Step 3. Explore variations and fill with peripheral atoms. Now, fill the remaining valencies of the carbon atoms with the 10 hydrogen atoms for each unique network to complete the structures. Structure 1 from Network A, a straight, continuous chain of 4 carbon atoms, common name. And butane, IUPAC name, butane. Structure 2 from Network B, a branch carbon skeleton where 3 carbons are in a row and the 4th carbon is bonded to the central carbon. Common name, isobutane, IUPAC name, 2-methylpropane. In summary, there are 2 constitutional isomers for the molecular formula C4H10, butane and 2-methylpropane. Similarly, problem 1C, draw all constitutional isomers for formula C5H12. Start with the longest continuous chain. Draw all 5 carbons in a straight line. Then attach 12 hydrogen atoms around them. Form isomer 1 pentane. Every carbon gets 4 bonds total. Shorten the main chain and add a branch. Reduce the chain to 4 carbons. Place the 5th carbon as a methyl group on carbon 2. Connect the hydrogens. Form isomer 2, isopentane or 2-methylbutane. Notice that placing the branch on carbon 3 instead would just yield the same molecule flipped. Shorten the main chain further. Reduce the chain to 3 carbons and place 2 methyl groups on the central carbon. Isomer 3, neopentane or 2,2. Dimethylpropane is central carbon bound to 4 CH3 groups. There are exactly 3 constitutional isomers for C5H12. Problem 1D. Draw all constitutional isomers for C4H10O. Here, oxygen adds exciting layer. Oxygen is divalent, meaning 2 bonds. It can sit between a carbon and hydrogen, forming an alcohol, or between 2 carbons, forming an ether. Part A. Alcohol 4 carbon chain variations. 1-butanol, a straight 4-carbon chain with OH at the end, position 1. 2-butanol, move OH to carbon 2. 2-methyl-1-propanol. Shorten the carbon chain to 3 carbons. Add a methyl branch to carbon 2 and attach OH to carbon 1. T-butanol 2-methyl-2. Propanol shorten the chain to 3 carbons. Attach OH and the methyl branch both at carbon 2. Part B. ethers, COC backbone. Diethyl ether. 2 carbons on the left, oxygen in the middle. 2 carbons on the right, CH3, CH2, O, CH2, CH3. Methylpropyl ether. 1 carbon on the left, oxygen. 3 straight carbons on the right, CH3, O, CH2, CH2, CH3. Methyl isopropyl ether. 1 carbon on the left, oxygen, and a branched 3-carbon group on the right, CH3, O, CH, CH3, 2. Result is C4H10O has 7 total constitutional isomers, 4 alcohols and 3 ethers. Similarly, there are 4 constitutional isomers for C3H6Cl2. To wrap up today's problems, whenever you're finding structural isomers, 1. Count valencies first to know how many bonds each atom expects. 2. Work systematically. Start with the longest carbon chain, shorten it step by step, and explore all branch positions. 3. Vary heteroatoms, oxygen, chlorine, or nitrogen, place them in all unique positions along the backbone. 4. Double check for duplicates. Always check IUPAC names or flip structures mentally to make sure you haven't drawn the same molecule twice. Practice drawing these out by hand would build your speed and intuition. Thank you for watching, and please subscribe for more.